Welcome back to another demonstration video hosted by yours truly, Harith. So in this video, we will be talking about the project that is given by Dr. Zuki, and with the help of my two members, EHSAN and FAWWAZ, we decided to take an approach towards the temperature and humidity, but this time with a range warning. So before we get started, what is a temperature? Well, as we know, the temperature is what surrounds us. It can be in the form of a hot or cold. So in this project, we will be using Celsius as the unit of temperature. Now moving on to humidity, it is similar to what the temperature is surrounding us, but in the form of water vapor. So we will be using in a percentage form for humidity. What is the point of designing this project? Well, there are many usage and applications that can be used to it. So let's move on to EHSAN.
In terms of application of this project, due to its flexible nature, it can be applied in a variety of fields. For example, in the process of manufacturing semiconductors such as the wafer requires precise temperature and humidity in order to produce the best wafer for consumer use. Moving on, in the fashion industry, producing silk is a very tedious process because silk is very dependent on humidity. Therefore, a slight imbalance in humidity can cause a change in tensile strength and also elasticity. Therefore, will require a very careful observation of humidity control. And lastly, the user can also use this project during jungle trekking, whereby high humidity can indicate a nearby water body. So a nearby water body can enable the jungle trekkers to keep on hydrating themselves in the case of high humidity deep in the jungle. They can also use this project to detect unwanted predators such as tigers or lions or any wild animals that may pose a threat to them.
Fascinating. There are so many places and locations that we can use this hardware, for instance, at home or in a cave. So let's move on to the circuit. As you can see, we're using an STM32F411RE, and there are two switches, which is the positive and the negative. What I meant by the positive is that it inputs a 1, which is connected to PB8, and PC13, which is the implanted blue button that is connected to the processor, inputs a 0. So there's two switches, one LCD and 6 LEDs, and a buzzer connected parallelly to level 6 LED. And the most important part is the temperature and humidity sensor. What is the point of all of these LEDs? Well, it is just a warning to the user that the value of the current temperature is closer to the user input temperature or humidity. So for example, let's say the current temperature is 20 degrees Celsius and the temperature that user input is 25 degrees Celsius. So how do we know which LED will turn on? 25 minus 20, and then that will be 5, right? So there are 6 LEDs, 6 minus 5, then 1. So there will be a level 1 LED will turn on. So assuming if the current temperature is 26 degrees Celsius and 25 degrees Celsius and the user input is 25 degrees Celsius. So 25 minus 25 is 0, and then 6 minus 0, then level 6 LED will turn on. Now when there is a level 6 LED turn on, all of the LED before that will also turn on. Like let's say level 3 turn on, level 2 and level 1 will turn on, but level 4, 5, 6 will not turn on. Now when level 6 LED turn on, it is connected parallelly to a buzzer. Now as we know, using KVL, a buzzer connected parallelly to an LED, the voltage is distributed equally. So that is when the value of the current temperature hits the user input temperature, then it will alert the user with a sound. The same goes for humidity. So we have already explained the fundamental of this project. Let's design the circuit. Now, after we designed the circuit, we actually tried to apply a more portable method for the user to use. So as you can see, the LCD is placed here, microprocessor here, LEDs of the range, in which is level 1, level 2, level 3, level 4, level 5, level 6, in that order. You can see it's green, green, yellow, yellow, and red, red. Red, despite its warning, green is almost close, yellow is nearly close, and red is danger. And as you can see, there's a buzzer here, and the temperature and humidity sensor is above the LCD, which is what to detect the temperature and the humidity. Now, if you look carefully, you can see there is a switch here. There's two switches, one that is connected to the processor and one that is external. So this processor, in this button, as I mentioned earlier, is negative switch, meaning it inputs at 0. And for external switch, we made it as a positive. So we designed it a positive, which is through 3.3 volts connected to the switch, connected to 10 kilo ohm resistor, then connected to the ground. And the PB8 is connected between the resistor and the switch, as you can see from the circuit. So what is the function of this blue button and the external button? Well, the external button is to change the mode from temperature to humidity. So if the temperature, of course the temperature and the humidity will show, but the temperature warning will show. Either you want to detect the temperature warning or you want to detect the humidity warning. It depends on this button. Now this blue button is to change the value of the temperature warning or humidity warning. So when you press the blue button, it will go to a setup where you want to change the value, and to increase the value you press this external switch. Let's see through the procedure. As you can see, it shows a setup for your warning temperature. So to do that, we try to press this external button and it will increase. Now, assuming if you want to set it to 30 but then it's already passed, right? Don't worry, it will return back to 0 and give you another chance. It will go from 0 to 100 and it will try to increment again. So let's say we want to set it to 30 degrees Celsius as a warning, and then we press the blue button to go to the next setting, which is the humidity setting. So assuming this room is 76%, right? So let's try to put it at 80 degrees, 80%. We'll see later on there. Okay, so once again you press and it will try to set it up, and it is set. And as you can see, the current temperature is 29 degrees Celsius and the humidity in this room is 74%. The temperature warning is 30 degrees Celsius, and you can see it is only one value close to the temperature warning. So like I said earlier, 30 minus 29 is 1, 6 minus 1 is 5. So 5 LED will turn on from the order of green to red. So the buzzer and the LED is not yet activated because it is not reached the 30 degrees Celsius. So as you can see, for the external button, you press again, you change the mode of the humidity. Humidity warning is 80% and the current humidity is 73%. So it is nowhere near the 80%. So it won't lit up the LED. However, since this is 73%, right? We try to change it to 75%. Let's try to 75%. So this set warning temperature, we can set it to 30 degrees Celsius again, or 31. And then moving on, we change the humidity to 75 or 76. You can hold the external button and it will increase automatically, and press singular over that, and after that you press this and it will set. Now as you can see, the yellow LED changed back to red and then red turned back to yellow because the humidity in this room changes accordingly. So assuming if the value is exactly to the one, what will happen? So as you can see, when I try to spray some water vapor, the humidity surrounding it will affect the sensor, in which increases the percentage and increases above the warning. So since it reaches the warning, it will activate the beeper and also the LED. Now let's try the temperature. Since temperature is quite difficult, it provides the same function as the humidity. Either you put it less or above. But as we know, our point is 27 degrees Celsius and with a 46% humidity. That is our center point for the average sensor. So as you can see, the temperature warning is 23 degrees Celsius and the temperature right now is 26 degrees Celsius. So it's reduced. As it is close to the temperature warning, the LED will try to blink and try to illuminate. Now the current temperature is 25 degrees Celsius. As the cold atmosphere is going to be lower and lower, the LED will illuminate closer to the temperature warning. Okay, so we already tested in hot and cold temperature and also in different room humidity. So let's go to FAWWAZ for the discussion.
Assalamualaikum, my name is Muhammad Amir FAWWAZ and I'm here to discuss about our program, specifically its limitations. The most prominent one lies in the sensitivity of our program. In our program, the code was written in a way that the user can only input whole numbers as their desired value. This limits the practicality of our program as the user cannot use it to detect small changes in temperature and humidity of their surroundings. The next limitation lies in the ease of use of our program. When the user wants to input their desired value, they need to press the button multiple times in order to reach the desired values, as each button press increments the value from 0 to 1 and it increments it by 1 for every button press. Furthermore, if the user accidentally exceeds their desired value, they need to press it until the display shows that the value has reached 100, so that the value will be reset back to 0 so that the user may try again. This procedure is inefficient and can be improved upon by using keypad instead of using buttons, so for the user to set the desired values. So that is all for me. Thank you.
Okay, thank you FAWWAZ for the discussion and observation. It is true that we actually went through some limitation. For instance, initially we wanted to use a keypad, however some of our keypad had sensitivity issues. For instance, as you can see closely, there is like a straight line between the wires of the keypad. So it affects the sensitivity. The coding was a success, however, when we try to input an A, it enters an A, but it moved towards another value which is a B, and then it goes back to A and then B and then A, and then it becomes an alternative. So we believe the issue is due to the wiring of the keypad towards this wire. There were some complication with the LCD where the pixel is lost, so we find an alternative and buy a new LCD. So I guess that is all for today. I hope you enjoy our video and our demonstration. Leave a like and subscribe and comment down below if you have any questions.